In this video, we're going to look at a few other ways of how the properties of logarithms that we've studied can be useful. Right, quick recap, these are the three properties of logarithms that we've been working with. Right, when we add these two logs, log base b of x plus log base b of y, that's equal to log base b of the product here, x times y. And then if we subtract these logs, log base b of x minus log base b of y, that's equal to log base b of the quotient, x divided by y. And then the last property, y times log base b of x, that's equal to log base b of x to the y power, right? So these three properties that we've been working with, we're going to do a little bit more with these and see how they're useful in another way. All right, so let's take a look at these problems, right? So instructions say, use the following information to approximate the value of the logarithms below. Right? So we want to approximate this, log base 6 of 20. Right, and 2, same thing, log base 6 of 5. We want to approximate these logarithms. Right, and we're given these three logarithms. We're saying we're given this fact that log base 6 of 10 is approximately equal to 1.29, that log base 6 of 2 is approximately equal to 0.39, and log base 6 of 3 is approximately equal to 0.61. And we want to use these three facts to try to figure out good approximations of these logarithms here. All right. Well, so what we can do is we can apply our properties of logarithms, right? And let's think about the numbers that we have here. We have log base 6 of 20, right? And I know 20 is related to 10 and 2, right? So here's what we can do with this. We can say log base 6 of 20. Well, I know 20 is the same thing as 10 times 2. Right? So I could rewrite this, log base 6 of 20, as log base 6 of 10 times 2. Right? And then I know with my properties of logarithms that when I've got a product here, I could say this is equivalent to log base 6 of 10 plus log base 6 of 2. Right? So I can break that up into two logs that are being added. And then now, hey, I know that log base 6 of 10 is approximately equal to 1.29. So I can replace this with 1.29. And then I know that log base 6 of 2 is approximately equal to 0.39, so I can replace that with 0.39. So log base 6 of 20 would be approximately equal to 1.29 plus 0.39. And if I add that together, that's equal to 1.68. Okay, you might have to do the adding off to the side, but if you add those together, you get 1.68. All right, let's look at another one. This time I want to approximate log base 6 of 5. Right, and so I want to kind of think about the number 5 and how that might be related to any of these other numbers. Right, well, what I see is that 5, another way to write 5 is the same thing as 10 divided by 2. So I could rewrite this as log base 6 of the quantity 10 divided by 2. Right, because 10 divided by 2, that's the same thing as 5. Right, and now our properties are come in handy again, right? Because I know if I have a quotient here, I could rewrite this as a subtraction of two logs. I could rewrite this as log base 6 of 10 minus log base 6 of 2. Right? And again, now I can use the facts that I've been given. Log base 6 of 10 is approximately 1.29, and log base 6 of 2 is approximately 0.39. So log base 6 of 5 is approximately going to be equal to 1.29 minus 0.39. Right? And if you subtract that, you're going to get 0.90. And there's our answer. All right, I'm going to do one more, and then you're going to try some. Okay, so the same three facts that we're given, and we're going to use these three facts, or maybe not all of them, but we're going to use those to approximate this, log base 6 of 27. Right? So one thing I recognize here is that 27, that's a perfect cube. So I could rewrite this like this, log base 6 of the quantity 3 cubed. Right? Because 3 cubed is the same thing as 27. Right? And now I can use my third logarithm property. Right? I can use this exponent and put that in the front. So log base 6 of 3 cubed, that's equivalent to 3 times log base 6 of 3. Right? And now I can use this fact here, that log base 6 of 3 is 0.61. Right? So log base 6 of 27 would be equivalent to 3 times 0.61. Right? And 3 times 0.61 is 1.83. Okay, if you multiply that out. Alright, so this right here, 1.83, that's our approximation of log base 6 of 27. Alright, you're going to do 3 of these. Okay, so same 3 facts you're given. Log base 6 of 10 is approximately 1.29, log base 6 of 2 is approximately 0.39, and log base 6 of 3 is 0.61. I'd like you to pause and try to approximate the value of log base 6 of 30 and log base 6 of 16. Go ahead and pause and do that. Alright, let's check, see how you did. Okay, so what I see here is 30 is related to 10 and 3. So I could rewrite this as log base 6 of the quantity 10 times 3. And then using my logarithm property, I could rewrite this as log base 6 of 10 plus log base 6 of 3. Right, and so this would be, log base 6 of 10 is 1.29, approximately 1.29, and log base 6 of 3 is approximately 0.61. Right, and so if you add that all together, that's going to be 1.90. Let's do this one. Log base 6 of 16. Alright, 16. I know that's related to 2. So I'm going to do this one as log base 6 of 2 to the 4th power. Right? Because I know 2 to the 4th power is the same thing as 16. And so I can rewrite this as 4, using the log property, 4 times log base 6 of 2. And this tells me that log base 6 of 2 is about 0.39. So this is 4 times 0.39. And if I multiply that, that's 1.56. Okay, you're going to do one more, right? And this one is a little bit trickier. You're going to need definitely more than one property. Okay, and let me say it again. You're going to need to think about using more than one property. All right, so please go ahead and pause and try this one. All right, welcome back. Let's see if you got this one. So right away, I see that I have a division here. So right away, I think I'm going to go ahead and separate that. Right? I know that if I have a log of a division, I can rewrite that using subtraction. So I could rewrite this as log base 6 of 1,000 minus log base 6 of 9. All right? So now that's the good first step. I'm not quite done yet. 1,000, I know that's related to 10. That's 10 cubed. And 9, I know that's related to 3. 9 is 3 squared. So what I'm going to do here is I'm going to rewrite this as log base 6 of 10 cubed minus log base 6 of 3 squared. All right, and how does that help me? Well, now I have these exponents here that I can bring to the front. So this would be 3 times log base 6 of 10 minus 2 times log base 6 of 3. All right, so this would be, we would be able to approximate this as 3 times 1.29 minus 2 times 0.61. Right, and if you multiply these out, let's see, 3 times 1.29, that's going to be 3.87 minus 1.22. And if you subtract that, you get 2.65. All right, and one more thing I want to mention. I'm not multiplying these out in my head. I mean, maybe you can, but just for the sake of time in the video, I multiply these out ahead of time. But if you will need to be able to do these without a calculator, so I would just do the work 3 times 1.29 off to the side, right? 2 times 0.61, do that off to the side, and then again subtract. All right. So we'll practice some more of these. I'll see you in class.